Hello everyone, I'm Frank, and this is Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Double Exclusion, and it's by Mikeso. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or box. We also have quadruples, where digits in a quadruple circle must be placed at least once in the 4 cells touching that circle. So for example, 1 and 4 must be in at least one of the cells that is surrounding this circle. 1 and 2 similarly has to be in one of these 4 cells surrounding this circle, etc., etc. 3 has to be in one of these 4 cells surrounding this circle. And that's how that works. And 3, 4, and 5, for example, has to be in one of these 4 surrounding cells touching this circle. We also have double arrow, where the sum of the digits on the line between two circles is equal to the sum of the digits in the circle at either end of the line. Or basically, the sum of the digits on the circles that are at the end of the line. So for example, these 4 digits must, we'll get 4 digits here. These 4 digits must sum up to what these 2 digits sum up to. So you could have something like 8 and 8, and you have, I don't know, 2, 3, 5, and 6. Does that work? Yes, okay. Because 2, 3, 5, and 6 adds up to 16, and 8 and 8 add up to 16. So therefore, the double arrow, the digits on the line between the two circles must add up to the endpoints, essentially, of these lines. And that's how double arrows work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so one thing that was interesting here. This is at most 18, right? Actually, this is at most 18. All the digits, the double arrows, can only add up to 18 at most. This 18, though, because these digits are all unique, and you cannot have a 1 or 2, because in the box, the 1 and 2, there has to be a 1 next to this quad circle, and there has to be a 2 next to this quad circle. Therefore, 1 and 2 can never be on this line. Well, what's the minimum of 4 digits, 4 unique digits that cannot have 1 or 2? It's 3, 4, 5, and 6, right? Well, what does that add up to? That's 18. So this must be 3, 4, 5, and 6. This must be 9 then, and this is 9, because that adds up to 18 here. Well, I'm guessing we could probably do something similar, like with these arrows. But because there's no 9 available now, that means these have to be at maximum 8 and 8. So that means 16 now is the biggest for these lines to add up to, right? Well, what's the minimum if you don't have 1 and 4? You have 2, 3, 5, and 6. That's the minimum you could have for 4 unique digits without a 1 and 4. Because we have the same reasoning here, right? 1 and 4 have to be surrounding this quad cell. So there cannot be a 1 and 4 in the rest of the box, therefore cannot be on the line. So the minimum would be 2, 3, 5, and 6. Well, that adds up to 16, which is a maximum now that these two circles can add up to. So the minimum here must equal the maximum here, therefore they must be the same amount. And I think it's similar for this one, right? If you have 2 and 3 here, the minimum amount for these 4 cells must be 1 plus 4 plus 5 plus 6, which is 16. And this is maximally 8 and 8, because you can't have a 9 in either cell. So this must be 8 and 8. This must be 8 and 8. And these have to be 2, 3, 5, and 6. And this has to be 1, 4, 5, and 6. What's the minimum here? So this can maximally go up to 18 again, because you can have a 9 and a 9 here. Well, this is 1, 2. They cannot have 3, 4, and 5, because the 3, 4, and 5 in the box have to be surrounding this quad circle. Goes quadruple it. And so the minimum here is 1, 2, 6, and 7. Well, that adds up to 16, right? 1, 2, 6, and 7. Um, uh, 1, 2, 6, and 7 adds up to, it's 3 plus 13, it's 16 at least. So this has to be 16 at least. So it has to be either 7 and 9 adding up, or it could go up to 18. So this could have okay. Can it ever be 1, 6, and 7? I think the answer is no, right? Because if it's 1, 6, and 7 here, so it'd have to be 1, 6, 7, and 8 at minimum, if without a 2. So 1, 6, 7, 8 adds up to 22, which 2 digits can never add up to. So this always has to have 1, and it always has to have 2. For we know that for certain. So 1 and 2 have to be here. What about these digits? These digits are at most 7 and 7, because this cannot be 8 or 9 because of 8 and 9 here. This cannot be 8 or 9 because 8 and 9 here. Also, 8 cannot be here in this middle box. Can't be here, can't be here, can't be here, can't be here. Whereas the 8, it must be here. 9 cannot be here or here. So 9 has to be one of these 3 digits. And we need a 6 or 7 also surrounding this quad circle. So this must be then 6, 7, and 9. That means this is at most 5. This has to be 1 through 5. And in the box, the 3 has to be one of these 2 cells. So this cannot be 3 here. So this is 3. You could have 1 and 5 here. So 1 could actually be here, technically. In this box, we know the 1 has to be in rows 2 or 3. Actually, the 2 has to be in rows 2 or 3. In this box, we know the 2 has to be in rows 2 or 3 also. So that eliminates 2 from the rest of rows 2 or 3, because we have 2 2s already set in those 2 rows. So these cannot be 2. Whereas a 2 in this box here, then, it has to be one of these 3 cells. So this is at minimum 1 and 3 adding together. With a similar logic, 1 has to be in rows 2 and 3. Actually, did I say rows? These were columns 2 and 3 here. These are specifically, 1 has to be in rows 2 and 3 in this box. And in this box, you have to have 1 in rows 2 and 3, which eliminates 1 in the rest of rows 2 or 3. So 1 has to be here then. So this is at minimum 1, 3. This is at minimum 1, 4. or sorry, not 1, 4, 2, 3. Well, this adds up to 9, and this can never be 5 and 5 added together. So since this is a minimum of 1, 3, and 2, 3, that adds up to 9, this is maximally 4 and 5, which also add up to 9. So this must be 4 and 5 as a pair, which eliminates 4 and 5 from the rest of the box. So this can't be 4 or 5 here. We have this is forced to be a 3 because we need a 3 around this quad circle. So this is a 3, which makes this a 2, which makes that a 3. This can't be 1 because of the 1, 2 pair here. This can't be 2 or 3, and this can't be 3. Well, 2 in this box has to be one of these two cells because it cannot be here because of this 2. This 1, 3 pair also eliminates 3 from being here. This 3 means this can't be 3, so this is 1, which makes that a 3. This 1 eliminates that 1, so that's 2, which makes that a 1. So this can't be 2 anymore here. This 2 eliminates that from being a 2, so this can't be 2 here. This can't be 1 because of this 1. This can't be 3 here because of this 3. So one of these 2 digits must be a 3 to surround the quad circle here. That 3 here eliminates that from being a 3. We now have a 4, 5, 6 triplet in this box, which eliminates 4, 5, and 6 in the rest of the box. Therefore, this can't be 4, 5, or 6. It's 3, which eliminates that from being a 3. We now have a 5, 6, 5, 6 pair here, which eliminates 5 and 6 from the rest of the box. Therefore, this can't be 5 or 6. We have a 6, 7, 9 triplet in row 6, which eliminates 6, 7, and 9 in the rest of the row. We also have a 6, 7, 9 triplet in column 6, which eliminates 6, 7, 9 in the rest of the column. So none of these can be 6, 7, or 9. Where is the 6 in row 6 and column 6? Well, you can't have any 6, 7, 9s in the blank remaining cells. It has to be one of these two. Well, where is the 6? Therefore, this can't be 6. Where is the 6 then in column 6? Because of the 6, 9, 7, 9 triplet in column 6, these can't be 6, 7, or 9. So it has to be here. So this is 6, which means this cannot be 6. Remember, this had to add up to 16 at least, and therefore that's why we know these are 7 and 9 specifically. Well, this can't be 7 or 9 because of the 7, 9 pair in the row. This can't be 7 or 9 because of the 7, 9 pair in the column. There has to be a 9 in the surrounding quadruple circle in one of the 4 cells around this quadruple clue. So it can't be here. Can't be here, it must be here. So this is 9, which leaves these as the remaining 3, 4, and 5 here. We also know this specifically adds up to 16, right? These two digits, if this were 9 and 9, that would force both of these to be 7s, but you would have a duplicate in the same box. So this has to be 7 and 9, adding up to 16, which forces this to be a 1, 2, 6, 7 triplet, or a quadruplet, because they have to add up to the maximum here, which is 16, and the minimum here is 16. Therefore, they add up to the same digit. Well, what does that leave here? This must be an 8, because that's the only digit remaining in that box. Since this is an 8, these can't be 8, these can't be 8, these can't be 8. And where is the 8 in this box? It must be here. Therefore, this can't be 8, this can't be 8. Where is the 8 in this box? It has to be here. This can't be 8, this can't be 8, and these two can't be 8 because of these 8s, so this leaves that as an 8 here. Remaining digits in this box are 1, 4, 5, 1, 4, 7, and 9. But 9 cannot be here. 9 cannot be... 9 cannot be here, 9 cannot be here. In this box, actually, that's probably better. Therefore, 9 must be here in this box, which means this can't be 9. We have a 1, 4, 7 triplet now in this box, which means this has to be a 9. Okay, 1 has to be one of these two digits because this can't. This one eliminates that from being a 1, and one of these has to be a 1. This is also 1, 2, and 7 as possibilities, but this can't be 2 because of that 2. This can't be a 1 then, because one of these two is a 1. So we know 1 has to be one of these two here. What are the remaining digits in column 6? Well, you can't have 6, 7, 8, or 9, so it's 1, 2, 3, 4, 5. But this cannot be 2 or 3 here, so this is 1, 4, 5. This must be 4, 5, because it can't be 2 or 3. And the remaining digit, well, we have a 4, 5, 4, 5 pair, also in column 6. That eliminates 4 and 5 in the rest of the column. Therefore, this must be 1. This can't be 1. This is 2 or 3, and this must be 2 or 3. Well, similarly, in row 6, what are the remaining digits? They can't be 6, they can't be 7, 8, or 9, so it must be 1 through 5. But this can't be 1 or 3, and it can't be 2. This can't be 1 here. It can't be 2 because we need a 2 here, right? So this has to be 4 or 5 also, which eliminates 4 and 5 in the rest of the row. This can't be 1 or 3 now, so this must be then 2, which makes this a 1, 3 pair here. This can't be 2, but in this box, we know that 3 has to be one of these two digits, which means it must be in columns 7 or 8. In this box, we know 3 has to be one of these 3 digits, and also has to be in column 7 or 8. So we have 2 3s which are required to be in column 7 or 8. That eliminates a 3 from the rest of column 7 or 8. So this cannot be 3. This must be a 1, which forces this to be a 3. This can't be 1 anymore. This can't be 1. Since this can't be 1, where is the 1 in this box? It has to be one of these two digits, which eliminates 1 from being here. So 1 has to be one of these two digits. Well, we know 1 has to be in one of these two digits in this box here. And then 1 has to be in one of these two digits in this box. And they're both in row 7 and 8. So that eliminates 1 from the rest of row 7 or 8, right? Because we have 2 1s already set that have to be in rows 7 and 8. And again, you can only have 2. You have to have 2 and exactly 2 1s in every row, and in 2 rows or 2 columns, right? So 1 cannot be here, 1 cannot be here, 1 can't be here. Where's the 1 in this box? It has to be here. So this is 1. Let's see. We have a 9 here, a 9 here. That eliminates 9 from being here and here. And it can't be any of these two cells because of the double arrow constraint. So where's the 9 in this box? It has to be here. One of these two must be a 9. One of these two must be a 9. That's not that helpful, though. Okay, let's mark these colors. This is orange. We're going to make this yellow. Since this is the other 7 and 9, this cannot be the yellow one. It must be the orange one. And this can't be the orange one here, so this must be the yellow one. What about these? We're going to mark it dark and red. This must be the dark one, and this must be the red one. Okay. This is a 6, so this cannot be 6 here because of the 5, 6 pair in the column. Therefore, one of these must be 6, so this can't be 6. So we have a 4-5 pair in this box, which eliminates 4 and 5 from the rest of the box. So this can't be 4, 5. This has to be a 1-6 pair, which eliminates 6 from being here. The rest of this is 4, 5, or 7 here. Well, where then is... We have a 4, 5, 7 triplet in this box, which eliminates 4, 5, and 7 in the rest of the box, which makes this a 6. This can't be 6 here, where we have a 4, 5 pair now, which eliminates 4 and 5 from the rest of this box, which means this a 6 also. We have a 4, 5, 4, 5 pair in row 3, which eliminates 4 and 5 in the rest of the row. Therefore, this can't be 5. This is 6, which makes that a 5. And this can't be 4. Therefore, this must be a dark also. This cannot be dark. This must be red, which makes this a dark. The red then has to be here. Where is this red? The red has to be one of these two. What else do we have? We have 4, 5, 6, 7 remaining in row 4. Well, this can't be 5 or 6, so this is 4 or 7. We now have a 4, 5, 7 triplet in row 4, which eliminates 4, 5, and 7 in the rest of the row. Therefore, this must be 6, which means this cannot be 6. Where is the 6 then in this box? It has to be here. So this is 6. In row 5, the remaining digits are 2, 4, 5, 7, and 9. Well, this cannot be 9, and this can't be 9. This can't be 5. Oops. This can't be 5 here. So one of these two digits is a 5, which means this cannot be 5 here. What are the remaining digits in column 4? We have 4, 5, 6, and 7 also. This can't be 6, so this is 4, 5, or 7. This can't be 6, so this is 4, 5, or 7. Where is the 6 in column 4? It has to be here. And this 6 can't be 6 because of that 6. It can't be 4, 5 because of the 4, 5 pair here. Therefore, this must be 7 then. Which makes this a 2, which makes that 3, which makes that a 2. These two can no longer be 2s. We have a 1, 7 pair, which eliminates 1 and 7 in the rest of the column. Therefore, this can't be 7. This is a 4. This can't be 4 or 7, so this is a 2. So there's no 2 or 4 here. This 4 eliminates that 4, so all the darks are essentially 5. And all the reds are 4s. Well, we don't know which one that is, so these are all 4s. This 4 and 5 eliminates 4 and 5 from that cell, so this must be 7. This has to be 4. This 7 means this can't be 7, so this is 9, which makes this a 7, which makes that 9, which makes that a 7. This 7 eliminates that 7. It can't be 4. This must be 5 then. This 6 means this can't be 6, so this is 1. This is 6. This 1 eliminates that 1, so that's 7 and 1. These digits are 4 and 5. 2 cannot be here. We have a 3, 4, 5 triplet here, which eliminates 3, 4, and 5 from the rest of the row. So this has to be 2 and 7. And this must be a 3. These digits are 6 and 7, but this can't be 6 because of that 6, so this must be 7, this must be 6. This 7 means this can't be 7, so this is 5, this is 9. This 2 eliminates that 2, so this is 3, this is 2. This 7 eliminates that 7, so this is 1, which makes that a 7, which makes that 2, which makes that 1. This 2 eliminates that 2, so this is 7 and 2. This 7 eliminates that 7, and it can't be 1, so this is 4, this is 7. This can't be 3 or 5, so this is 4, which makes that 5, which makes that 4. This can't be 3 or 4, so this must be 5, and this must be a 3. And that's how you solve that. Pretty cool, actually, use of these constraints, right? Yeah, it was pretty straightforward, I think. I would probably make this a slight tick above very easy, but it's not quite an easy level puzzle also. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.